Today we are going to give a presentation on the human perception of time. So, time itself isn't something you can exactly perceive. It is not something you can actually pick up with any one of your five senses. This is a super easy thing to argue about. But essentially, we can perceive changes in time, often through events or kind of just different changes in other situations. And this perception is often what you think about when you're thinking about perceiving time. So, events and the changes make up time as we know it. The past and the present and the future are always what we refer to when talking about time, but the only one that you can actually experience is the present. The past and the future are things that you can only perceive in your brain. You can only think about them. You can't actually experience the past or experience the future, because if you were currently experiencing something, then that would be the present. It's all a bit complicated. But essentially, the events of the past and the future cannot exist in the present because those are separate situations. And that's what makes our brains the only source of past and future time. So this does bring up the question of if the past and future can be real, if they're things that we just create in our imagination. So the specious present can be defined in more than one way, but essentially this is a term to define like the section of time that you're actually experiencing as the present, because you can experience more than one event in the present without them happening simultaneously. You can often think about this about when you're listening to a song or a sentence or someone talking. You have to listen to the rest of the words in that sentence or the lyrics to that song to really understand what's happening. So you're experiencing them all in the present, but not at the exact simultaneous moment. So all of these definitions are different ways to define this period of time that you experience as the present and how long that period can last and how in the world this is possible to perceive something as present but also extended over a period. So that is what specious present defines. Essentially, the chunk of time that you're experiencing as present, no matter how long that small chunk of time is what the present is when you're referring to time. And as far as the order of time, the brain represents time through ordered events and experiences. So essentially, event X will affect your perception of event Y if that happens later. This is a unique representation of time. It means that everybody's really going through a completely different thing because you're experiencing different events and different orders, and that's affecting how you perceive time. So what you perceive occurs over this interval of time that we just talked about, but since we can perceive motion and also what we perceive is present, that's how we can observe more than one thing within the present over that interval.
So now that we've discussed how time can be perceived, we can discuss some of the mistakes that come along with it. So, obscuring of consecutive events. When two or more events happen within close succession, the order of perception of time and our perception of space can become a little bit obscured. Take, for example, knocking on a door. When you knock, there's a lot of information that our brain has to take in, and it needs to process. The movement of the knocker, the sound the knocker makes, and the color of the door, just to name an obvious few. All this happens on the order of milliseconds, and all of that information is sent to all different parts of the brain in order to be processed. This information processing takes a little bit of time, and none of it happens at the same speed. So the color might register a little bit sooner than the sound, than the actual movement. So there's a bit of perceptual lag here, which leads to improper processing of events, and we might even hear the sound of the knock at the same time, or even a little bit before we actually see the knocker hitting the door. Of course, this is a very small obscurement, and it happens on the magnitude of milliseconds, but it can be scaled up onto a larger lead to a larger mix-up of chronological events that occur one after another. In the study here, the time theories are discussed. Researchers researchers designed an experiment where people are shown the color and direction of lines. To effectively identify the correct color and the correct direction change, people needed roughly 80 milliseconds. So this kind of set up a benchmark on the amount of time that it takes for a concept to become established in the area of the brain. In other words, the amount of time that it takes for that information to be processed. This delay is known as brain time theory, and in this theory, time is treated a little bit differently than the other senses. On the other hand, in event time theory, the temporal perception is kind of treated like another sense, just like sight or taste, and it's thought that it might have a unique mechanism, just like sight has the eyes and taste has the tongue. Okay, so a little bit of the illusions and the problems that come with this perceptual lag. So what kind of illusions are we going to see? There's a famous example of the stopped clock experiment. Imagine you're sitting in a classroom waiting for lecture to end, and you glance over at the clock, but the second hand appears to be frozen. You look at the clock a little bit longer, and the second hand just keeps on moving. This is a common phenomenon, and it's known as the stopped clock illusion. There's a very good reason for it, actually. Our eyes make very, very fast movements called saccades when we look from one thing to another, and between these movements, there's a momentary blur in our vision. This would be very disorienting to constantly see blurring whenever you want to look around, so your brain actually doesn't recognize it. Since our visual system replaces that missed time with the next thing that we see, we don't get all disoriented. This is known as saccadic masking. So our brain is actually filling in that blurred time with the first image of the clock that we kind of catch, making that first second that we're looking at this stopped hand seem a lot longer than all the others. This same illusion is the reason why the lines on the lower picture here appear to move a little bit, and why you can never quite see the movement of your own eyes in a camera or in the mirror. David Eagleman, a neuroscience researcher, wrote on this phenomenon of time dilation by motion. It's been shown that subjective duration of event can be dilated by the amount and magnitude of motion that occurs within that period. This is an inaccurate perception of time, and it also plays into the illusions such as the stopped clock. When our brain sees the second hand move, it slows down, and the period in which we see that stopped second hand appears to be much longer than it actually is. So, human perception of time when observing the outside world, specifically under a very short period of time, can be very flawed and truly disorienting. Okay, so here we have a little bit about the two forms of brain time that we discussed on the previous slides. In the explicit form, otherwise known as brain time theory, relative time is thought to be encoded into neurons that are sensitive to time, so not necessarily dedicated to time. However, this is subject to some temporal delay that we discussed earlier, and the actual perception of events tends to become incorrect. So this theory isn't always sound. The implicit form is a little bit more complicated, and it involves an external mechanism dedicated to perceiving time. So, following from this, in order to make judgments about that information, such as creating an order of events, you have to consider the order of processes occurring in different parts of the brain at different times and different speeds. This application of the obscuring, mentioned previously on the last slide, this is an application of that obscuring. As a result, the implicit form requires this mechanism outside of the neural substrate. So it's not super important to know what the neural substrate is, just that it would be very comparable to how something like hearing or sight would work. This is virtually impossible to replicate and test for. However, so we can't really prove it. Additionally, this implicit form would break that link between neural activity and perception. So things tend to get a little heavy and very scientific when we look on this level. And the result of this break is what's known as event time theory, as shown on the slides. Okay, so these inaccuracies, as previously mentioned, happen over a very, very small interval, where the brain is not given enough time to process the information, but brain time theory proposed in the paper by Johnston and Nishida, when scaled up onto the macro level of minutes and hours, does not present many issues. So in other words, we don't really see these mistakes in perception when we're dealing with everyday lives going about our days. So whether time is processed via neurons or some external mechanism, there are still some flaws in perception that we see across literature and science in our own lives. The concept of time dilation, which we discussed about, can be seen in Common Time by James Blish, which we read this semester. And in this story, the protagonist is put in a situation where this time dilation and actually time restriction causes him to remain sane, remain alive. Similarly, our brains kind of self-preserve, and in a situation of stress, when a lot of stimuli are happening, we tend to slow things down to perceive them easier. And obviously this can lead to some illusions, but it can also help us out and allow us to perceive things better.
One of the most common perceptions of time is the perception that time passes faster as one becomes older. The common saying that time flies, or where did the time go, have basis in psychology and physics. The human mind perceives reality through visual stimuli that reaches the cortex in the brain. The mind senses a change in time when an image changes in the brain. The time arrow in physics is a sequence of changes whose direction is directed by something called the constructal law. The constructal law is a law that supports the flow and organization of everything in nature and the world. Clock time, or the measured flow of time, is different than mind time. The time that one perceives is different than the time that another person perceives. In the figure shown, the displayed perceived image changes in age, decreases as one gets older, while still each making up for the same amount of clock time. This leads to a perceived duration of one time unit increase as one gets older. This contradicts the classical model of time perception, where one standardized clock tick happens at a constant rate. Experiments done on perception measuring saccades or eye ticks to fixed points that measure a perceived change in image show that these saccades in the elderly lag behind those that were young or middle-aged, indicating that they perceive fewer perceived changes in images. This evidence gives increased support to the idea that time perception speeds up with age.
All right, and I think everyone has heard the phrase time flies when you're having fun. But can it really be proven? Well, time is not kept in a singular part of the brain. It is not interpreted in a singular part of the brain. Instead, the brain is more of a network, and so it runs in between a bunch of different compartments inside the brain. So it would be reasonable to assume that emotional responses can also affect the perception of time because, well, they're a part of the brain. All right. So there are experiments that went to go ahead and prove this. At the very least, they went to prove that perception of time can change when someone is stimulated. One of the best ones that I could find was one at the Universiteit of Amsterdam and their experiment, which tested the oddball effect. Essentially, subjects were sat down and shown a series of very similar images with one or two stranger ones thrown in there. These images were shown for the same duration of time, and so what happened is that after the test happened, each subject was asked how long they perceived each image to have taken place. The images which were not the same as the other images, the weirder images, were perceived to have taken a little bit longer than the other ones, even though they all, in reality, took place at the same time, showing that when stimulated, the brain will interpret time differently. Now, how can emotion affect that? Well, within the University of Alabama, there was an experiment to see whether positive stimulation could affect the mind's perception of time. In a similar experiment as the one previously mentioned, subjects were shown a list of images with ones that would positively stimulate the brain thrown in there, such as desserts. When asked about their perception of time, when shown the different images, people perceive the ones with desserts to actually be faster, showing that positive stimulation does in fact make people perceive time in a faster manner. And then on the flip side of things, there are experiments done to see whether negative stimulation could alter one's perception of time. In one experiment, Subjects were asked before they went skydiving what their level of fear was for what they're about to do. Those who ranked higher on their amount of fear told researchers after that they had gone through the skydiving that they felt as though the skydiving had gone on for far longer than it actually had. And on the flip side of that, people who were not afraid, people who were more experienced with the situation, felt as though the skydiving had taken just as long as it had actually taken up in real time. Now, why does all of this happen? Well, as far as positive stimulation goes, when someone sees something, their memory and attention process becomes honed in on it. It becomes narrowed. So any unnecessary thoughts or feelings that would occupy someone's thought process, or occupy someone's head, are just moved out of the way. And as far as negative stimulation goes, that is something a bit more primal. It's that fight or flight instinct. When someone experiences fear, their mind might slow down their perception of time in order to better react and comprehend the situation. Now, in conclusion, time is an order of perceived events, and our brain influences the duration of time we perceive. Our perception of time can change with age, and emotion does actually have an impact over our perception of time. I'd like to thank you for coming to this presentation, and here is our list of citations.